Good morning, everyone. Sorry I'm not here today. I had a TWSAA meeting in Nashville. Unfortunately, I know some of you guys don't like it, but we're going to have to watch a video today. So, should be a really simple day. Obviously, I'm just starting the recording, so I don't know exactly how long it'll be. But I want to go through last night's answers and then jump back to your note sheet and finish up this idea of simplifying radicals. So today we're dealing with variables, and I think you'll do well with it. So let's go ahead and get right in. I'll go ahead and go through all of these since I'm not here today. So remember, in the directions that we have right off the bat, this wants all the possible roots. So since they're asking for all the possible roots, remember, when it's an even root, like the square root of 225, we have to remember that it could be both positive and negative. And then, of course, the square root of 225 is 15. So it could be plus or minus 15. Okay? Now, as we move along to the cube root of 512, remember that's an odd root. And when we deal with an odd root, our answer is going to have the same sign as the radicand that's inside. So what multiplies by itself 3 times to get 512? It's 8. So our answer is only positive 8. Number 3, same concept. That's an odd root, cube root. So since that sign inside with that radicand is negative, our answer is also going to be negative. And what is it that multiplies by itself 3 times to get 64? That's 4. Negative 4 times negative 4 times negative 4. Okay? And then the last one where it asked me about all the roots is a fourth root. So again, kind of like number 1, it's going to have 2 answers because it's an even root. And we're just trying to find what is it that multiplies by itself 4 times to get 1296, and that is 6. Okay? So there are your answers for numbers 1 through 4. Pretty simple. And that moves us into number 5, where we have to simplify radicals. See, look, if I go back to my notes, 150 is not in my list of perfect squares. Now, how do I know I'm looking at perfect squares? Remember, if there's nothing here in that root spot, it's understood to be square root. So we're looking at perfect squares. So when I want to break down 150, I'm trying to find the biggest perfect square that goes into 150. So remember, we divided by 2, 75. And I'm going to zoom out a little bit. And I may not do this every time, but I just want to remind you, we're looking at this list of perfect squares. And 150 divided by 2 is 75. So that puts us right in here. So I'm not going to try any value up there. It would be a waste of my time. So I just grab my calculator real quick and I just start going, okay, what about 150 divided by 64? Does it divide evenly? No. How about 49? 150 divided by 49? Definitely not. How about 36? 150 divided by 36? Again, no. How about 150 divided by 25? There it is. So 25 is the biggest perfect square that goes into 150, and 25 goes into 150 6 times. Now, again, and we talked about this yesterday, and I think you guys were doing pretty good with it, but why did we do it this way? Why did we look for a perfect square? Because they're the only things that have the ability to escape out of that radical. See, since 25 is a perfect square, the square root of 25 equals 5. It comes out of the radical. It's no longer underneath a radical. Therefore, I can multiply it by the 5. Well, what is 5 times 5? Well, that's 25. So 25 is outside, and that leaves 6 trapped underneath that square root all alone. So our answer is 25 times the square root of 6. Okay? Now, number 6, also, look, there's no number here. It's understood to be square root, so we're thinking only of perfect squares. So 63 is definitely not on my list. So I divide that into 63 divided by 2 is what? 31.5. Again, I'm not going to go up every time, but 31.5 is right in here. So I'm not going to look at any value up this way. It's a waste of my time. I'm only going down. So 63, will it divide evenly by 25? Definitely not. How about 16? Again, definitely not. How about 9? 63 will divide by 9. Okay, so let me go back up. 63 will break down using 9. So don't forget this negative 8, it stays outside. But we're breaking 63 down with 9 times 7. That's how it breaks down. 9 times 7 equals 63. That's how we're breaking it down. Again, why? Because 9 is a perfect square. Therefore, it gets to escape that square root as a 3. Okay? Square root of 9 equals 3. So now that it's on the outside, I can now multiply it by negative 8, right? That was negative 8 times square root of 9. So now it's negative 8 times 3. So that's negative 24 times the square root of 7. And it's done. Then we move into cube roots. Okay, cube roots. Again, look, you can see it. It's got a cube right there. Cube root. So the only difference is I'm now focused on my list of perfect cubes. Okay, I'm looking right here now. I'm not looking at perfect squares anymore. Okay, now 875 is definitely not on it. So if we divide 875 by 2, and that's a pretty big number, but 875 divided by 2 is what? 437.5. That's right here, 437.5. I'm not going to check any value above this point. So I start with 343. And I just start clicking away. Okay, I go 875 divided by 343. Doesn't work. 875 divided by 216. Doesn't work. 875 divided by 125. 7. It works. So there it is, okay? I'm going to go back up here. We are breaking this down. Instead of the cube root of 875, we're going to do the cube root of 125 times the cube root of 7. Okay? 125 was the only perfect cube, or the first perfect cube we found, and it goes into 875 7 times. Again, why do we do that? Because perfect cubes get to break out of cube roots. What multiplies by itself 3 times to get 125? Well, 5 does. So 5 gets to escape, and then the cube root of 7 remains. 7 gets locked in. There it is. Okay? Moving on to number 8. Number 8, we've got negative 54. Obviously, it's cube root of, so we're only thinking about perfect cubes. So, again, I'm going to look, and I won't scroll up this time. You can look on your own paper. What is the biggest perfect cube that goes into 54? Well, divide it by 2, you get 27. And if you look at your list, sure enough, 27 itself is a perfect cube. Now listen, I haven't written this yet, but because we like to take negatives out of radicals, I'm going to let the negative come out with that perfect cube. Now, what is 27? What is 54 divided by 27? Well, it's 2. So you still have the cube root of 2 locked away. So we let this cube root of negative 27 turn into a negative 3, right? Okay, the 27 is 3 cubed. So 3 comes out, the negative comes out with it. So 2 times negative 3 is negative 6. And then, of course, inside that cube root, 2 is locked away. So negative 6 times the cube root of 2. And then the last two were fourth roots. So again, we're only going to focus on our perfect fourths for this. So if you look at your list, 567, I'll scroll up, 567 is not on my list of perfect fourths. So I'm going to take 567 and divide it by 2, and I get 283.5. That's right here. So I'm only working my way down from here. So let's start with 256. And I might be on the wrong problem here. Let me go back. I kind of lost my place. 567 divided by, and again, you can scroll through your list of perfect fourths. 567 divided by 256. Nope, that don't work. Okay, 567 divided by 81. There it is. It works. 81 goes in there 7 times. So let's scroll back up. We're going to break this down with 81 times 7. So negative 3 drops down. But we're going to do the fourth root of 81 times the fourth root of 7. That's how we're able to simplify this radical, because the fourth root of 81 allows this to escape as a whole number 3. Okay, 3 to the fourth power gives me 81. So 3 gets to break out of there. Now, you have a whole number negative 3. You have a whole number positive 3. Multiplying those, negative 3 times 3 is negative 9. And then the fourth root of 7 gets trapped inside. So it's negative 9 times the fourth root of 7. And last one, number 10, 6 times the fourth root of 405. I'll go up one more time. 405 is definitely not on my list. See, 405 is somewhere around in here. So I'm going to divide that 405 by 2. So 202.5. So I'm not looking at anything above here. So 405 divided by 81, does that work? Yeah, it actually does. 405 divided by 81 is 5. So let's finish this one off. So the 6 is going to drop down. But then we're going to do the fourth root of 81 times the fourth root of 5. And again, just like the last problem, the fourth root of 81, since that's a perfect fourth, it gets to escape as a whole number 3. But that 5 right here gets trapped inside. These are both whole numbers, so I can multiply those. 6 times 3 is 18 times the fourth root of 5. And that's it, okay? That's how we simplify radicals. Now, maybe that's a little more complicated than what we did a while back when we did these, but anyhow, it's nothing that you guys can't handle. So what I want you to do is go to your note sheet now that you got yesterday, and we're going to add to what we did yesterday dealing with variables. Okay, look, the difference between these problems and the ones above is that all these have variables. So we'll start with square roots. Anytime we're dealing with square roots, again, when it comes to numbers, we treat numbers differently than we treat variables. For a number to escape, it has to be a perfect square itself. But for an exponent on a variable to escape, it can escape if it's a multiple of the root, which in a square root is a multiple of 2. Do you understand that? It has to be a multiple of 2 to come out. Okay, let me explain, and we'll go to cube roots when we get to cube roots. If you look at 9 and 10, both of those are clearly square roots, right? Because there's no number written in these two spots. We know that they're square roots. So here's what we're going to do. We're going to focus first on our number, okay, the 32. Is 32 on my list of perfect squares? No, 32 is not on that list. So I divide by 2, that's 16. Well, sure enough, 16 is. How do we break 16 down? Or I'm sorry, 32 down with 16. Well, 32 is divisible by 16 twice. 16 times 2, okay? And then, of course, we've got the square root of x to the 4th, y to the 9th. Now, as you guys get better at this, then by all means, you can kind of skip the step that we're doing. So while I'm teaching this, I want you to see it this way, though, okay? So what happens to the square root of 16? Remember, it's a perfect square. It gets to break out as a whole number 4. But 2 gets trapped inside. Now, I'm leaving a little space here because now we got some variables. So we've taken care of this. This is done, okay? We can move on now to our variables. And here's how it works. In order for a variable to escape a radical, it's not that 4 has to be a perfect square or that 9's a perfect square. It's all about being a multiple of 2. So here's what we do instead. Instead of saying, hey, is 4 a perfect square? No, you don't do it that way. You say it like this. How many times will 2 go into 4? Well, it goes in there twice. So x gets to escape twice. Now remember, that's 2, right? That's understood to be square root. That's a 2. So 2 times 2 is 4. So all of these got to escape, meaning there is no x left inside. But a little different than that. How many times will 2 go into 9? Divide it. Go 9 divided by 2. Well, 9 divided by 2 is 4. Y gets to escape 4 times. But what is 4 times 2? 4 times 2 is 8. Only 8 of these y's actually got to escape. So how many were left inside? Well, 9 minus 8 is 1. So y to the first got stuck inside. So our answer, simplified, is 4x squared y to the fourth times the square root of 2y. Now, hopefully that's not confusing too many of you. We're going to keep working through some examples. So if you didn't get that immediately, just be patient, okay? So let's move over here to number 10. Number 10, still square root of 324. And then you've got a cubed b to the 7th. So let's start with the 324, okay? Is 324 a perfect square? Well, remember, it's not on my list because my list only went up to 100 yesterday. So remember how I told you guys we could check to see if something is a perfect square? I told you to go second x squared, and let me get my calculator open. I told you to go second x squared. Let me reset my calculator. It's always a smart thing to do, right? We're going to go second x squared, and then we're going to check 324. Well, sure enough, it is a perfect square. So 18, the square root of 324, 18 gets to break out completely, okay? Now, we're still dealing with the square root of a cubed b to the 7th, okay? So here's what I do next. All right, the 18 we've taken care of, but what about a? Does it get to escape any? Well, yeah, because remember, this is understood to be a 2. How many times will 2 go into 3? Well, 2 will go into 3 one time. So a gets to escape one time. Now remember, that's 1 times 2, right? That's what that exponent is. So 1 times 2 is 2. So 2 of these actually got to escape. 2 of them. Well, how many are left inside? Well, 1. 1 is left inside. So a is left inside. See, when a came out, it came out because there is one multiple of 2 in a cubed. It was a squared. But I had 3 in there, so 1 got stuck inside. Okay, same with b. How many times will 2 go into 7? Well, I know y'all know that answer. That's 3. So b gets to come out to the third power. But that's 3 times 2. What's 3 times 2? 6. Well, there was 7 in there. If 6 of them came out right here, how many is left? Just 1. So our answer is 18 ab cubed times the square root of ab. Okay? I hope that makes sense. I could show you something else that might help. So let me just do that real quick, actually. See, basically, here's what's going on with these variables. A cubed, basically inside here, since this is a root of understood 2, I'm trying to find or break these down into multiples of 2. So essentially, you have a squared and a to the first. Then, to get b to the 7th, we got b squared, that's 4, b squared, that's 6, and b to the first. So what's happening is all the multiples of 2 are getting to come out. So that's 1a getting to come out. But that leaves 1a in. That's 1, 2, 3 b's coming out. But that leaves 1b in. That's essentially what's happening here, y'all. Multiples of that specific root are getting to escape the radical. So as we move to the next grouping, we're moving into cube roots. And in order for a variable to escape cube roots, it has to be a multiple of 3. Okay, hey, that's not rocket science here. I hope that makes sense. So look at number 11. It's cube root. Let's worry about the number first. 216. Is 216 a part of my perfect cubes? Well, let's go up here and look. Yeah, 216 is a part of my perfect cube. See it right here? Now that's 1, 2, 3, 4, 5, 6. That's cube root of 216 is 6. So I'm going to go ahead and let 6 completely come out of here. And then let's just focus on my variables. That's the cube root of n cubed into the 6th. So think about this, guys. In order for a variable to come out, it has to be a multiple of 3. How many times will 3 go into 3? Once, right? So m gets to come out once. Well, that's 1 times 3, which is 3. So 3 of them got to come out. So how many m's are left inside? None. They all come out. Okay, go to n. How many times will 3 go into 6? Twice. So n gets to come out twice. That's 2 times 3. That's 6. So all 6 of these came out. Well, if all 6 of them came out, how much is left? None. There is no variable or no radical still left. The answer is 6mn squared. All right? Move over here to number 12. Is 56 in my list of perfect cubes? Let's go look. Is 56 in my list of perfect cubes? No, it's right here. So let's divide 56 by 2. 56 divided by 2 is 28. Let's not try a perfect cube above 28. Well, I know 27 won't work. So let's try 8. That's the only thing that could work. Will 8 go into 56? Absolutely. So let's go ahead and break this down with 8. So we're doing cube roots of, right? So we're doing the cube root of 8 times what? Well, 56 divided by 8 is 7. So 8 times 7. And then off the side, I'm going to write the variables. You got the cube root of r to the 8th, s to the 4th. We'll worry about that in a minute. Let's focus first on the numbers. The 8 gets to escape. The cube root of 8 is 2. So 2 comes out, and 7 is trapped inside. Now, let's go to the variables. Now that we've taken care of our numbers, let's go to the variables. How many times will 3 go into 8? Well, 3 will go into 8 twice. Okay? Not evenly. It'll go in there twice. 8 divided by 3 is 2 point something. So r gets to come out twice. Now, what is 2 times 3, y'all? 2 times 3 is 6. So only 6 of these r's were able to escape. Well, if only 6 of these 8 r's escaped, how many are left inside? 2. All right, next. How many times will 3 go into 4? Once. So s gets to come out once. Now, 1 times 3 is 3. So only 3 of these s's came out, and there were 4. So there is 1 s still trapped inside. So I know that looks crazy, but our answer is 2r squared s times the cube root of 7r squared s. All right? Let's look at number 14 right below it. This one's pretty challenging. Again, let's start with the cube root of negative 81. Now, 81 looks like it might be a cube root, a perfect cube, but it's actually not. If you go up here to your perfect cubes, 81 falls right here. So divide that by 2, that's 40.5. So don't try any perfect cubes above 40.5. So let's start with 27. Will 27 go evenly into 81? Absolutely. 27 does go into 81 3 times. So here we go. Let's do the numbers first. We're going to do the cube root of, and we're going to let 27 come out. We're going to put the negative with it. And that means that the cube root of 3 stays inside, right? Negative 81 breaks down with negative 27 and 3. But don't forget, you still have this cube root of p squared q to the 12th. We'll worry about that in a minute. Right now, our focus is the number. What is the cube root, of negative 27? Well, it's negative 3. And then this cube root of 3 stays trapped inside. So here we go. We are finally to the variables. How many times will 3 go into 2? Well, 3 doesn't go into 2. So that means no p's get to escape. They both stay inside. How many times will 3 go into 12? 3 will go into 12 4 times. Q gets to escape 4 times. Again, what is 4 times 3? Well, it's 12. That means all 12 of these came out. So none of them are left. So our answer is negative 3q to the fourth times the cube root of 3p squared. I hope this is not too hard for us. We're going to move in and do a couple more. And these, of course, are your fourth roots. So we're only looking at our fourth roots. Now, fortunately, on number 15, there's no number. This is just variables, okay? So look at this one. How many times will 4 go into 4? Once. So W comes out once. And what is 1 times 4? Well, it's 4. So that means every single one of these W's came out. This is done. Now, how many times will 4 go into 17? If you don't know, just divide. 17 divided by 4 is 4 point something. So V gets to come out 4 times, right? Well, I don't know why I did 2 different 4s. What is 4 times 4? 4 times 4 is 16. So 16 of these V's came out. Well, if 16 of those V's came out, how many are left? 1. So V is left alone inside. So W, V to the fourth, times the fourth root of V. That's our answer. Okay, number 16. Number 16, again, 48. We're going to look at our perfect fourths, and we're going to see if 48's on it. So here's our perfect fourths. 48 is not on it. If I divide 48 by 2, that's 24. Don't try a perfect fourth above 24. So let's try 16. Well, 16 divide evenly into 48. Well, absolutely it does. 16 goes in there 3 times. And then we'll leave our variables at the end to do at the end. So, what happens to this fourth root of 16? Well, it gets to break out because there is a number that multiplies by itself 4 times to get 16, and that is 2. But that 3 gets trapped inside. So let's go ahead and do that. Now we're ready to move right here. And we start with m. How many times will 4 go into 8? Well, 8 divided by 4 is 2. So m gets to escape twice. And 2 times 4 is 8. So all 8 of these escape. There's no m's left inside. Now, how many times does 4 go into 3? Well, 4 won't go into 3. So no n's get to escape. They all get stuck inside. So this answer is 2m squared times the fourth root of 3n cubed. Last one we'll do is right here. And let's start with the 625. I'm going to scroll up one more time. Is 625 a perfect fourth? Yeah, it actually is. It's 1, 2, 3, 4, 5. 5 to the fourth power gives me 625. So fortunately for this one, 5 gets to come all the way out. So there's no more number inside here. The fourth root of 625 is 5. So let's go ahead now and let's focus then on the fourth root of c to the 23rd, d to the 11th. Now you probably need your calculator because most of you guys probably don't do those great in your head. If you do, that's great. But let's see what happens next. How many times will 4 go into 23? 23 divided by 4 is 5 point something. So C gets to escape 5 times. Now what is that? Well, 5 times 4 is 20, right? So 20 of these C's got to escape. Well, if there are 23 here and 20 escaped, how many are left? 3. And the next, how many times will 4 go into 11? 11 divided by 4 is 2 point something. So D comes out twice. Now, what is 2 times 4? 8. 8 of these were able to come out. So how many are left? 3. So our answer is 5c to the 5th, d squared, times the fourth root of c cubed, d cubed. So that is how you deal with variables. In order to come out of a square root, it has to be a multiple of 2. In order to come out of a cube root, it has to be a multiple of 3. In order to come out of a fourth root, it has to be a multiple of 4. And that's how they can come out of those variables, or out of those radicals as variables. Now we're not going to do 18 because I don't want to. I don't like that question. So your homework tonight is to finish up 11 through 19. And we will check that on Thursday, 11 through 19. All right, I hope you guys have a great rest of your day, and I will see you tomorrow.